15 seconds. Guidance is internal. 10, 9. Ignition sequence start.
Space Nuts.
5, 4, 3, 2. 1, 2, 3, 4, 5, 5, 4, 3, 2, 1.
Space Nuts.
Astronauts report it feels good.
Hello again. Thanks for joining us. You are listening to the Space Nuts podcast. Andrew Dunkley here, your host, and joining me, as always, is Professor Fred Watson, Astronomer-at-Large. Hello, Fred.
Hi, Andrew. How's it going? How's that hay fever going?
Oh, look, it's still pretty bad. Like I mentioned last week, we're having one heck of a pollen season due to recent rain and, of course, cropping, and all the weeds and the flowers are just going, yay! And it's created this massive pollen, which you can see in the sky as a haze. Now, you and I got to talking about something that pollen can cause, and I'd never heard of such a thing. So I took up the challenge to get a photo of it, and I did post the photo last week as a bit of a tease on our Facebook page and the podcast group and on Instagram to see if I could sort of get people listening in to see what it was, because we're going to reveal it last week, and we did, and I did successfully get the photo of the pollen corona.
Yeah, great stuff. I was so happy when I saw your picture, because I thought, it's something I've only rarely seen. But when I lived up in, not very far from you, 150 kilometers away in Coonabarabran, this time of year, we often saw this phenomenon. So what it is coloured rings around the sun. I always had to shade my view of the sun, but you got a direct photo which includes the sun as well with those coloured rings, and they cause.
Yes, I basically just pointed my camera right at the disk of the sun, got it centered, touched the screen so that it would hopefully focus, and just pressed bang. I didn't look at the sun. I just sort of focused on the edge of the screen just to line it all up, and it worked beautifully. I was really, really happy with it.
Excellent. I was too. It's a great picture, and I suggested that you had a look at it because you mentioned the haze of pollen. If you've got that much pollen in the air, then you're very likely to see this pollen corona. And what causes it is the fact that the pollen particles, effectively, they're all the same size. And a concentration of similar-sized objects, small, microscopic objects in the air, produces an effect similar to something we call a diffraction grating, which is a device that we use to split up the light of stars and other objects in astronomy to look at their spectrum, the rainbow spectrum. And a diffraction grating is characterized by the fact that it's got all these, as the name implies, it's essentially a grating of regularly spaced bars through which the light passes. And so if you've got anything with regular size or regular spacing, you're going to get diffraction effects, and that's what this pollen corona is. And your photo is probably the best one I've ever seen.
Thank you.
Yeah, really good. And so despite your hay fever, which is the downside of it, you've done a great job capturing your pollen corona.
Well, I did get a similar photo last year during the drought, and when all the bushfires were happening around Australia, and we were constantly shrouded in smoke. Yeah. And the sun was setting one day, and I just happened to see, it turned into this beautiful orange orb, and I took a photo of it, and the photo revealed the same effect through the smoke. Not exactly the same. The colours were different. Yeah, but it did have a smoke effect type of corona breaking the light up. It's a stunning photo as well, if I do say so myself.
Yeah.
I took a lot of really, really great photos last year that I was going to put in our annual show in the photography competition, which I've never bothered to do before, but they were such amazing photos and really demonstrated the effect of the atmosphere on the sun. But because of another form of corona, we didn't have a show. Exactly. So I couldn't. Exactly. I couldn't put my photos out there for judging, but I was pretty confident that they'd do well because some of them look amazing. I mean, we've got different levels of smoke changing the colour of the sun. So you've got the disk of the sun in 3 shades of orange. And another one that looks like staring at Jupiter. It is really Yeah, it was some incredible effects. I should do a sort of collage of them and put them on the Facebook page so people can see what I'm talking about. Yes, I will do that. I will. Now, down to business, Fred.
Yeah.
We are going to look at these topics. Death by spaghetti. Now, we've talked about something like this before. It's actually happening. Not to a person, thankfully, but to a star. The OSIRIS-rex mission will get you. We'd sort of get a preview it, but by the time you hear this, the mission would have reached a critical point, and there would be information coming out about it, and we will follow it up next week, but it is certainly worth talking about because it's reached the exciting phase. And another follow-up is that of the film Interstellar. Now, we were asked if that situation with the gravitational time dilation on the planet, where 1 hour on Earth turned into 1 hour on the planet turned into 7 years on Earth, could happen. And we suggested no, but we have been sent information that reveals under certain extreme circumstances, it may be a yes. So we'll look at that. And we've dug deep into the letterbox. I mean, we have gone gouging right down into it and found an old question that we must have overlooked from June of 2019 from Carl in the Netherlands about Gravistars. So we thought that's worth doing. We don't want to leave anyone out. I mean, we have to these days because we get so many questions, but we've got a bit of a question drought going at the moment. So hopefully that'll change soon. So we just sort of went through the list to see if we've missed anything interesting, and that one came up. So we'll get onto that too. Lots to talk about today. First of all, Fred, death by spaghettification. It's happening as we speak. Or it's happened and it's all over, but we're only just seeing it now.
Well, that's right. Yes, there's that side to it as well.
Clarify that.
So we've talked about spaghettification before in the region of a black hole, where you've got a situation where the gravity is changing so rapidly across space, basically, that if you were approaching a black hole feet first, you'd come to a point where the gravitational pull on your feet was greater than the gravitational pull on your head, and you'd be stretched or spaghettified. It would be, in the case of a human, it would be extremely messy. I don't even like to think about it.
I don't think you'd get to witness it for very long.
No, that's probably true. It wouldn't be something that would occupy you for too long. However, so this story is not about a person getting spaghettified, but a star, because observations which have been made by the telescopes, some of the telescopes of the European Southern Observatory, excuse me, down in northern Chile, place called Cerro Paranal. That is where the four giant telescopes of the VLT, the Very Large Telescope, are based. And I think one of those has been used in this work, as well as an instrument, actually, which is also ESO operated. It's called the NTT, which was the New Technology Telescope, built actually before the VLT, and it was designed to show some of the technologies that would be used for the VLT, but it's still doing great stuff. So last year, these telescopes observed a flash of light close to a supermassive black hole, and were, the analysis equipment that they had on board was sufficiently good and sufficiently well tuned to the problem to recognize that this is basically the result of, as one of the authors describes it, an unlucky star that wandered too close to a supermassive black hole in the center of a galaxy. And the extreme gravitational pull of the black hole has shredded the star into thin streams of material. That's Thomas Weavers, or Wevers, I'm not sure how his name is pronounced. I think it's Weavers, who's in Santiago in Chile. He's an ESO fellow, a European Southern Observatory fellow, also at Cambridge University. So what he's saying is, you get this process of spaghettification. It churns the star up into these thin strands, And as it falls into the black hole, you get a bright flare of energy, and that's what they observed. But there is there's a bit of a catch to this, because the theory shows that if you have this situation, as soon as the black hole's swallowed up the star, you get a cloud of debris, a cloud of dust that's blasted outwards riding out on that energy, and that stuff actually obscures your view of the star being gobbled up. So normally, a phenomenon like this would not be visible, because the dust cloud very quickly obscures the action. So the reason why this particular team managed to see it was because they were very hot off the mark in terms of recording the details of the event. By the way, the technical term is a tidal disruption event, but spaghettification is a much better name. So one of the other authors, who's actually Kate Alexander, she's a NASA Einstein Fellow at Northwestern University in the United States. She says, because we caught it early, we could actually see the curtain of dust and debris being drawn up as the black hole launched a powerful outflow of material with velocities up to 10,000 kilometers per second. This unique peak behind the curtain provided the first opportunity to pinpoint the origin of the obscuring material and follow in real time how it engulfs the black hole. So really extraordinary work that, it basically comes about because this team has been looking at sky surveys. So once again, Thomas Weaver's several sky surveys discovered emission from the new tidal disruption event very quickly after the star was ripped apart. We immediately pointed a suite of ground-based and space telescopes in that direction to see how the light was produced. So that's basically what they did. They followed up on the sky survey events. Really, really.
So they weren't necessarily looking for this. They just noticed something and went, "Oh, what was that?"
Well, this team is interested in exactly this kind of work, though. But yes, it was that sort of thing. So surveys picked up the flare. They immediately followed up, and it's a credit to their, the speediness in bringing these giant telescopes to bear on this very distant galaxy, whose name I haven't told you, Andrew, but it is called AT 2019 QIZ. What a great name.
Oh, nice. Yeah, I've forgotten it already.
Yes.
But, yes. I suppose the other thing that pops into my head is, we know how difficult it is to actually photograph or see a black hole. So when you see these kinds of images, I mean, what are you actually looking at, or are you not looking at an image specifically?
Yes, they were in this case. The ESO website actually has a very nice artist's rendition of what is happening, of this process. That's nothing like what they actually saw. Most of what we see when this kind of work is going on, Andrew, is done spectroscopically. That's to say, you use the spectrograph to produce probably spectra in real time. So the rainbow spectrum giving this, the signature of all the different elements that you're looking at, and also other phenomena like the velocities that are involved. Those spectra you can interpret in such a way that you can actually build up the picture of what's going on just by looking at the way the speeds are changing, things of that sort. So that is what these observations would have been about. I have to say, I do have a reference to the paper in which this work was published. It's in the monthly notices of the Royal Astronomical Society, that one of those great journals that astronomers use to publish their data. I haven't had time to have a look at it, but I will do, because it's that will reveal exactly how these observations were made. I'm surmising from what I know of the way these things tend to work that it is all done spectroscopically.
The interesting part is if they didn't have to publish the credits at the end of that paper, the paper would only be on 2 sides of an A4 page. So
you noticed that as well. There are rather a lot
massive credits. It's worse than the end of a movie.
Well, that's right.
But, it's hard work, and it's worth getting your name out there when you've achieved something like this. So, that's terrific.
I think the Event Horizon Telescope paper that we spoke about earlier, some time ago, that I think had 3,000 authors on it. So, the list of authors is longer than the paper itself.
Yeah, incredible. And well worth looking up. You're listening to Space Nuts with Andrew Dunkley and Fred Watson.
Space Nuts.
Hello to our patrons. We would like to, again, thank you for supporting this podcast in whatever form you choose, whether you do that through patreon.com/spacenuts, Supercast or Acast. Putting a few dollars into the can for us every month is much appreciated and goes a long way. It certainly does feed Fred's pets. I think that's where most of the money goes.
Not where it goes. I wondered where.
It just gets eaten up, yeah. But we do appreciate our patrons. And, of course, as a patron, there are package deals that you can check out, especially through Supercast, where you can get 2 or 3 podcasts as a collective, or you can just choose what you want to spend as you see fit. For as little or as long as you like. It's totally up to you. And as I've said many times, not mandatory, but the benefits are good. You get an early ad-free edition and you get bonus material, which we published recently. So if you haven't chased that up as a patron, there's a couple of more segments in there for you to listen to. Now, Fred, let's move on to our next topic. That is the OSIRIS-rex mission, which, as we speak, has hopefully touched down successfully on asteroid Bennu.
That's right. So you're quite right, as you mentioned earlier, that by the time our listeners listen to this podcast, this will have happened, but we're recording beforehand. Really exciting stuff. So OSIRIS-rex, a NASA mission designed to explore the content of an asteroid, the soil content of an asteroid, and explore it literally by bringing it back home to Earth. The spacecraft has been in orbit for the last 2 years around an asteroid called Bennu, which is actually one in a rather Earth-like orbit. It's in an orbit that allows asteroid Bennu to approach the Earth in distances measured in hundreds of thousands of kilometers rather than millions of kilometers. So it's a near Earth object. The 2 years of orbiting around Bennu that OSIRIS-rex has been doing has allowed the spacecraft to give us really detailed images of this strange world, which is curiously shaped. It's shaped a bit like 2 cones stuck base to base. And it reminds me of the spinning tops that kids used to play with when I was young, back in the dark days of the 1950s and 60s.
I had one of those growing up. They were fun.
Yeah, they were great, weren't they? I remember playing with them as well. So that very much that spinning top shape, and it's apparently the asteroid has arrived at that shape because of its rotation. So it's an object that is probably more like a pile of rubble than a solid asteroid, but is an asteroid nevertheless. And the fast rotation tends to make the material migrate towards its equator. So you've got this thing that from the side looks like a diamond, but it's actually 2 cones base to base, effectively, because everything's slid down towards the middle. It's not very big. Its size is in the region of a kilometre. It may even be a bit less than that. Half a kilometre, 500 metres, and actually quite rough on the surface. The survey has revealed more than 200 large boulders, which was not really what people expected, because what they're going to do in the future for us now, and hopefully in the past by the time people listen to this, they're going to take a sample of the surface. And if you've got all these large boulders, that's the last thing you need. But what they've done is they've identified a region of the surface of the asteroid that's about 16 meters across, that is free of boulders, and that is where they will touch down in a maneuver that is called a touch and go maneuver. So the spacecraft has a robotic arm, which will be extended as it approaches the target area. That arm is equipped with a strange, it's almost like a suction device on the end of it, except it's not suction, it's blowing. It's got a disc which is fed by nitrogen, and the nitrogen is going to dislodge the surface, so it will land on the surface of the asteroid. The nitrogen blast actually lifts the soil from the surface, and then that is collected by the canister that is that this whole thing is surrounding. And the hope is that they'll get at least 60 grams of material. And in fact, they're kind of hoping for as much as a kilogram of stuff to be
good
blown up by this. Why is it so exciting? Because the materials that they are looking at, they're basically carbon-rich dust, but it was formed in hot water. That's the really interesting aspect of this. So who knows what might be in it? So what they say is that there are veins of carbonate material, which are, as they say, thicker than your hands. This is the team, which is led by Mike Moreau, who's the mission's deputy project manager at NASA Goddard Space Flight Center. What they're saying is that the parent body that Bennu has come from, and it's come from that parent body because the parent body was probably smashed up by something else early in the history of the solar system. Let me read what the account is. This is in a Science news release. Really interesting. It says that the prize that they're going for is veins of carbonate materials thicker than the hands, and Science is the journal in which this material is published. The minerals, which precipitate out of hot water, popped out of data gathered during a close flyby of light-coloured boulders near the target site, which is called Nightingale. Researchers believe the veins grew in channels of fluid circulating within Bennu's parent body, a large planetesimal thought to have formed beyond Jupiter's orbit soon after the dawn of the solar system 4.56 billion years ago, before being smashed apart in the asteroid belt within the last billion years. So heat from the decay of radioactive elements in its interior presumably drove the churning, and the presence of so much carbonate suggests a large-scale fluid flow, possibly over the entire parent body. That's a quote from Hannah Kaplan, who's a planetary scientist and actually the leader of this work. So a really interesting fragment of the early solar system that could contain, it could be rich in organic molecules, the sorts of things that generate the amino acids that we find in carbon-rich meteorites. So a really interesting, piece of work, and we hope that there'll be some interesting results from it.
Yes, indeed. Now, was Bennu specifically targeted for this reason, or was it just in the right place at the right time for a mission?
Yeah, I think it's a mixture of both. So what you do is you look for asteroids for which the spectroscopy, again, it all comes back to breaking up the light into rainbow colours, from ground-based observations would suggest that it had this rich chemistry on its surface. And then you find a handful of candidates of those and look for the ones that you can actually get to. So that's how it was chosen. It's a mixture of both of those things.
Yeah. So it's very exciting, and I'm sure there'll be a lot to learn from this little manoeuvre, the touch and go, as you referred to. But the downside is, I suppose, but this is typical of space travel, is we will not be seeing OSIRIS-Rex return to Earth until 2023 when it parachutes into Utah.
That's right.
What they probably don't know is if you parachute into Utah, you get arrested.
Yeah, probably. Quite true, yes.
Pretty sure parachuting's illegal in Utah.
Yeah, but might not be for it's from another asteroid.
There's some strange laws in the world, and they probably didn't think to check that one. But
I honestly
I'm only kidding. No offense to the people of Utah, but there are some strange laws in many places around the world. We've got some weird ones here that still hang around from 200 years ago that make no sense.
That's right.
But yes, very exciting time for the OSIRIS-rex mission and the people involved. So we look forward to finding out how it all goes. Well, you know now. You probably know, but we don't. But we'll talk about... We'll follow it up next week. It's a bit of a time warp, isn't it, Fred?
Time warp stuff. That's right. We're good at that kind of thing, though. We know what we're doing here.
Yeah, it's all professional. It's all professional. You're listening to the Space Nuts podcast with Andrew Dunkley and Fred Watson. This episode of Space Nuts is brought to you by LastPass, simplifying your online life. Now, if you're anything like me, you probably find one of your biggest frustrations in life is remembering all your passwords, all those login details, usernames, passwords, important information that have built up over many, many years. And you might have hundreds of them. I know last time I counted, I had like 88 passwords for various things, and it can get quite cumbersome. So what can you do about it? Well, I use LastPass. It's a password manager. It's a fabulous solution to this problem. And believe me, the relief is unbelievable, not to mention time-saving. Now, you can sign up for LastPass and you'll be joining 25.6 million fellow users from around the world and 70,000 plus businesses. With those kinds of numbers, they've got to be doing something right, and they do. In my experience, it has simplified everything. I've got every username, every password from everything I do built into LastPass, and it's integrated. I can use it on my desktop, I can use it on my laptop, I can use it on my phone, I can use it on my iPad. It's that simple, and it can even work in a way whereby you don't have to type in anything. You open LastPass, you type in what you're looking for, let's say it's your Gmail account or something, and it will bring it up and you just click on the link and it will open it for you. You don't have to do anything. It is really, really good. Now, you can get the premium package for around $4.50 a month, and there's a family and enterprise plan as well, and it works, as I said, across all devices. Put your passwords in, you can go into autopilot, you can reduce the stress. It's really fabulous. I highly recommend it, and it will give you peace of mind. You will never have to sit there going, oh no, I've forgotten my password. It's one of the worst feelings in the world, and this is the solution. It's really simple and highly secure. I mean, it is very safe. All you have to remember is a master password, one password, so that you don't have to remember any of the others. So check it out. Go to spacenutspodcast.com/LastPass and help support the show. Sign up and you can check it out for free at spacenutspodcast.com/LastPass and just simplify your life. Link details are in the show notes and on our website. Now, back to Space Nuts.
Roger, your lots are here also.
Space Nuts.
Don't forget when you visit our website to visit the Space Nuts shop. There's all sorts of stuff there. You can get a coffee cup, or more than one if you need more than one. I'm sure we've got more than one in our stock. They only got one in the photo, so, I could be wrong. There are caps, there are T-shirts, there are polo shirts, there's even a hoodie and a dad cap. That's a real winner, I reckon. So it's all on our website, spacenutspodcast.com. Check out the Space Nuts shop while you're there. Oh, stickers. We've got stickers. So if I believe we've been asked for stickers in the past. Well, we've finally done that too. So check it out. Now, Fred, we've got a follow-up, and then we're going to do a question that has sort of been sitting in the bottom of the post bag for way too long. But let's do this follow-up. A couple of weeks ago, we got a question about the movie Interstellar. Now, in one particular passage of the story, the astronauts went down to a planet that was under the gravitational effect of a black hole. And the story goes that spending 1 hour on the surface of what turned out to be a watery planet equated to 7 years back on the spaceship and therefore back on Earth. And was that indeed possible? Now, you and I basically came to the conclusion that it was way too extreme. The gravitational time dilation would not be that significant, not even close. But we've received a message that says, interesting discussion of interstellar. Heard this discussed on another recent podcast. Kip Thorne, Nobel Prize-winning physicist, came up with a solution that does work. The planet is orbiting the black hole at close to the speed of light. The speed of the planet provides the additional time dilation needed to make the movie logic work. True or false, Fred? I think I said that last time, but it sounds like they found a way.
Maybe so. That's right. So the problem with the original idea that it's just the gravitational time dilation that gives this huge amplification of time from an hour to 7 years. If you were in a gravitational field that would produce that sort of effect, you'd be spaghettified because you're in too extreme a gravitational field. It will be changing too rapidly because it's a black hole.
Okay, well, there's problem one for a start.
Yeah. So that was why we ruled out that amplification. But that's an interesting suggestion because there are two ways that relativity can cause time dilation. One is by gravitational fields, and that comes from the general theory of relativity. Gravitational time dilation, we call it. We are experiencing it as we speak on the surface of the Earth. Time is passing slightly more slowly than it is on the International Space Station, but not by very much. But the other way is relativistic time dilation, where you are moving at speeds close to the speed of light, and that slows down the passage of time as seen by an outside observer. Tried and tested many, many times. We know that relativistic time dilation works and is real. It was actually measured, I think, back in the 1940s by observing muons, which are subatomic particles that come down in cosmic rays, or they're caused by cosmic rays. And when they enter the Earth's atmosphere, they are traveling at almost the speed of light. And their decay time, as observed passing through the atmosphere, was much slower than it is in the laboratory. So because they're traveling at these relativistic velocities, so it does work. We know that relativistic time dilation is a real phenomenon. So an interesting thought, and yes, it would need Kip Thorne to think of this, very well-known physicist. An interesting thought to combine the two. And yes, maybe, just maybe, it's possible that if you're in orbit around the black hole at nearly the speed of light, which means you're very close to the black hole, I have to say, but never mind, then maybe you could get that significant 1 hour to 7 years time dilation. I'm prepared to believe it, Andrew.
Okay. It's brought up another problem. Let's assume for a moment that, okay, what they portrayed in the movie could happen.
Yep.
How the hell do you land on a planet that's moving near the speed of light?
Yeah, well, that's right. So you've got to have a spacecraft that itself is going near the speed of light.
Which we can't do.
Yeah. Well, you could if you had the engineering. You could get close to the speed of light. You can never get to the speed of light. But yes, I think you've got to suspend reality whichever way it goes. And my advice is, do not try this at home.
No, definitely not. When you're traveling in a car at 60 miles an hour, 100 kilometres an hour in the real world,
yep.
Is time dilation happening then?
It is, in the sense that if you drive past somebody, then in their time frame, your clocks are ticking more slowly. But to you, as you're driving along, everything's normal. It's the relativity between the stationary observer and the moving observer, which is where the difference comes. Of course, at 600 kilometres an hour, the time dilation is very, very small indeed. If anybody's interested in these things, there's at least one website, and I've forgotten what it's called. I'd have to look it up. But it gives you a little calculator. So you just plug in what speed you're going at, and it'll tell you what your time dilation is. So
wow,
quite nice.
That's cool.
Yeah, it's cool stuff. Yeah.
I'm glad I brought it up. And see, I was talking earlier about how professional we are. We don't remember websites or post them on our website or any of that. I mean, this is a warts and all a podcast. And we rely on the intelligence of our audience to figure it out for themselves.
No, that's right. I'm just trying to find in my bookmarks if I can find this website, and I'm afraid it's not turning up, which is a bit of a shame. I thought I'd be able to put my... Oh, here we are. Okay, it's on...
It's right in front of you. It's probably staring you in the face.
It's the Omni Calculator. So omnicalculator.com, and they've got a physics department in there. And in fact, the way I've got it set up here is for length contraction, because the other thing that happens when you're traveling at relativistic speeds is your length becomes shorter. But there are options on that to do time dilation as well. So have a look at the Omni Calculator and you'll get the answer.
There you are. Gosh, we just got even more professional. Amazing.
Oh, look,
and thanks to whoever sent us that information about Interstellar, because I have inadvertently omitted their name from my email, which I sent you, which you sent back to me because I lost it. This is how professional we are. But thank you for sending that info in. It really is fascinating. Let's go to our next question, which only dates back recently, Fred, 30th of June, 2019. Gee,
Yes.
we really dug deep, didn't we? Hey, guys, big fan of the show. Well, probably not anymore. Even catches up on previous episodes before I discover it. Recently, I heard about an alternative theory for black holes called Gravistar. Is this idea debunked now that gravitational waves have been discovered? With love from the Netherlands, Carl.
Yeah, thanks, Carl. And it's a great question. I'm sorry it's taken us getting on for a year and a half to answer this one. So a Gravistar is something that was hypothesized some years ago, I think, by two physicists as an alternative to black holes. And it's a really subtle difference, Andrew, and it's complex. It's all about the metrics that are used when you calculate these things. And in fact, it's just to throw in the definition, it's got the usual black hole metric outside of its horizon, but the de Sitter metric inside. Work that one out. These are actually they're essentially measurements of the geometry within a space that is disturbed by gravity. And the idea is that there isn't an event horizon. There's a thin shell of matter instead. And apparently the term comes from the words gravitational vacuum star, Gravistar. So I don't really want to say much more about it because I am not an expert on the relativistic equations that determine what's going on here. But there is, they're subtly different from black holes. But I think the crucial difference is that a Gravistar does not have an event horizon. It's got this sort of something they call a positive pressure fluid, and I don't want to go into the details because I don't understand them myself yet, but there is a subtle difference between a Gravistar and a black hole, which is that a Gravistar doesn't have an event horizon, but we know that black holes do, and we've seen them because the Event Horizon Telescope observations, which were made, I can't remember whether it was the beginning of this year or the beginning of last year. It's crazy, isn't it? I think it was the beginning of last year.
Yeah.
Just because of COVID-19 time dilation, it screws up your.
That's what it is.
Yeah. But when we observed the Event Horizon, the EHT, the Event Horizon Telescope, that revealed exactly what you would expect to see with a black hole, and so I think Gravistars probably are now debunked. at least as far as your average supermassive black hole is concerned. To me, looking at the theory, it seems really quite almost contrived. It seems like a really complex theory to get around problems that I'm not really sure what the problems are that they're trying to get around, because black holes are inherently simple. They're just a point where density is infinite and everything else follows on from that. These things are much more complex. So thanks very much for the question, Carl. I think the answer is, there aren't any gravistars.
Okay, that's a pity because they sound impressive. But never mind. And by the way, Carl, the reason it took us so long to get to your question was because we were under the influence of gravitational time dilation, because we were visiting a planet that was too close to a black hole. Although it could have been close to a gravistar. We're not real sure, but several months passed while we were recording one single episode of Space Nuts.
I have to say,
that's what happened.
I have to say that is the single worst excuse that I've ever heard. I think you should stick to, I'm afraid the dog ate your question.
Yes, I guess so. Yeah, that's an old one too. It could end up in a science fiction novel, though, I'm wondering.
There you go. Yeah, you better do.
Speaking of which, I'm 22 chapters into my latest book. It's just writing itself. Yeah, sometimes you just have ideas, and this one's got no plan. I'm just letting it write itself. I get to a certain point and go, okay, what could happen next, and let my brain mull it over, and then go, bing, there we go. So this one's all over the shop, but I do that on purpose. It's going to be fascinating.
And somebody's got to wind it all up at the end, which is presumably you, since you're the author.
Yeah, that's going to be the hard part, because I've got so many things happening at once. Yeah. I've got people in all sorts of different eras trying to do things that are being stymied by people in other time frames, and it's just really messy. And I've got to somehow bring it all in together so there's a conclusion that works. Of course, there's going to be a twist. It's just become my thing. There's no logical end to my stories, but They sort themselves out with a little bit of a boom tish. That's the way it'll go.
Very good.
I know how it'll end, but I'm just trying to figure out how to get there, because I've got to bring all these elements back into the,
of course,
into the one. And that I had the same problem with Parallax, because I had all these things that needed to be wound up and solve themselves before the story could end. So I got myself in the same pickle with this one, but it's a good pickle. It's fun. I enjoy it. Anyway, I don't know when it's going to be released. I don't know this is a long way to go yet. But we'll let you know. And the 4 people who've bought my last 2 books can maybe buy this one too. Who knows? I think we have to wrap it up, Fred. Thank you to everybody who contributed, even though they did it 18 months ago. But if you would like to ask a question of us, you can do that via our website. You can either type in the question via our communication portal, which is basically just an email interface, or you can click on the AMA tab and record your question for us. We really like that, but we'll take them as they come. And you do that at spacenutspodcast.com, spacenutspodcast.com, and just check out everything else that's on there as well. The Astronomy Daily tab is good because it keeps you up to date with some of the stories that are breaking around the world in astronomy, many of which we do discuss. Yes, spacenutspodcast.com. Time to go, Fred. Thank you so much.
Thank you, Andrew. Always good to talk, and I look forward to speaking next time.
Indeed. That's Fred Watson from Space Nuts, Astronomer-at-Large. And from me, Andrew Dunkley, thanks again for listening. We look forward to your company real soon.
Space Nuts. You've been listening to the Space Nuts podcast. Available at Apple Podcasts, Google Podcasts, Spotify, iHeartRadio, or your favorite podcast player. You can also stream on demand at Bytes.com. This has been another quality podcast production from Bytes.com.